In this video, we'll explore parameter packs in Swift and learn how to use them effectively. We'll start by attempting to implement a function without parameter packs. Our goal is to create a function that can receive an arbitrary number of parameters of different types and return a tuple containing all those inputs. Unfortunately, achieving this functionality without parameter packs is not possible due to several reasons. Firstly, it is not feasible to use an heterogeneous list of type parameters. If each type is different, we are required to explicitly list them in the function. Similarly, the same problem arises with the parameters themselves. We are compelled to explicitly specify each parameter. Furthermore, there's no way to generate the tuple dynamically. We need to add each property individually. That leaves us with one alternative, duplicating the logic to accept different types of parameters. This is problematic. The code is repetitive and relying on users to choose the correct number of parameters. Otherwise, more overload will be required to artificially hide the issue. In fact, you may have seen this issue in Swift UI's build builder definition, where multiple overloads of the build block method are required. These overloads are limited to holding up to 10 subviews. Some people could say, why not use any or protocols to solve this issue? Yeah, that might help to fix duplicated code for parameters, but with some compromises. With any, we will lose the type information and casting will be required in many situations. Using protocols may be a better choice, but this will work only if all the types conforms to the same protocol. And don't forget the performance implications with existential types. Also, none of them solve the issue creating tuples dynamically. Looks like this is the only way to implement this function. And if you look closely, this is the original problem generics tries to solve. Create an abstract syntax that avoids code duplication and improves performance through type checking at compile time. That's exactly what parameter packs do. Parameter packs will simplify this declaration. Instead of writing each type parameter one by one, we can use each keyword followed by the type placeholder to represent an n number of type parameters in this declaration. This is equivalent to a separated common list of types. For the parameter list, we will replace all of them with a repetition pattern using repeat each t. Depending on the number of type parameters, repeat each t will create the respective parameters for this function. This is equivalent to each parameter declaration separated by commas. Now, to create the tuple dynamically, we will apply the same repetition pattern, but this time using the input and not the type t. This is in fact equivalent to a list of values separated by comma, which is exactly what we need to do for tuples. And lastly, let's use the repetition pattern in the return type. This is equivalent to a comma-separated list of types. And that's it. This function can now work with any number of parameters to create a tuple. In fact, if you check the return type, it's actually a tuple. Before ending, let's fix one little issue. Zip function is accepting 0 argument, returning an empty tuple. That may be okay for some situations, but not for this use case. If you want to force to provide at least one parameter to this function, you can create a single type parameter before the parameter pack and creating a normal function argument at the beginning. Now the question is, how can I know if I need parameter packs in my implementation? If you look duplicated generic code like this, definitely you need parameter packs. Let me know in the comments what do you think about parameter packs, and don't forget that we have more Swift content for you, like this video explaining why if statement couldn't be returned by a function before Swift 5.9. My name is Pete and this is Swift and Tips. Thanks for watching and have a great day.